Okay, so I kind of messed up the first special case. It's Sunday afternoon, and I'm getting ready to go somewhere, so I'm kind of flustered. That's okay. We'll start over. So on the special cases, I'm going to use the graphing method, which means I need to set up my XY box for Y1, my XY box for Y2. First I'm going to replace x with 0, then y with 0. So in the equation x minus 2y equals 3, when I replace x with 0, I'm left with 2y equals 3. I divide it by negative 2, and I get negative 1.5. Whenever I replace the y with 0, it just cancels out that term, and I'm left with x equals 3. So that's how I'm going to do it from now on. 2x minus 4y equals 6. I replace x with 0, and that whole term disappears. And I'm left with negative 4y equals 6. Divide by negative 4, and I get y equals negative 3 halves, which is negative 1.5. And when I replace y with 0, I get 2x equals 6 divided by 2, and I get 3. So first I'm going to plot this point, go over 0 and down 1.5. Whoops, it's 2.5. Down 1.5. Then I go over 3 and down 0. Connect my 2 points. Start at 1.5, over 3 and 0, and I get that point. Now watch what happens. I go over 0 and down 1.5. I'll wind up back on that same spot. And then I go over 3 and down 0. I wind up on that same spot. So it is the same exact line. So I have this situation going on. Let me do it with the pen. I have the first line I graphed, and then this is the second line I graphed. That means that they're both the same lines sitting on the graph. So that means there are infinite solution. So there are infinite solutions to this problem. So guess what the next one's going to be. I'll start my 2 boxes. In case you're wondering, the reason I don't put x1 and x2 is because it's always the same number. 0. Well, I guess not. But it's just the x variable. We don't label it x1 or y1 in the box. You'll see why when we get to the calculators. So I'm going to do my math. X minus 2y equals 3, negative 3. This one is 2x minus 4y equals 3. So if I replace x with 0, I'm left with negative 2y equals negative 3. That just leaves me with, if I divide a negative by a negative, it's positive, so I equal 1.5. When I replace y with 0, that just leaves me with x equals negative 3. So if I draw that line, I go over 0, up 1.5 this time. Then I go negative 3 and up 0. And I connect those 2 lines. It's a little wonky, but you get the idea. Now I'm going to replace x with 0. That leaves me with negative 4y equals 3. Divide by negative 4. And this is negative 3/4, or we'll call it 0.75. Then I'm going to replace y with 0, and that leaves me with 2x equals 3, or when I divide by 2, x equals 1.5. So I go over 0 and down 0.75. 0.75 is about right there. And then I go over 1.5 and up 0. And I connect the 2 lines. And if I had done this one correctly, There we go, that looks a lot better. You can see that I just created two parallel lines. So that means that there is no solution to this problem. Parallel, perpendicular, it's a little, parallel and no solution and infinite solutions a little harder to do graphing wise. It's really easy to see with infinite solutions, but not so much with the no solutions, depending on how well you draw your lines. When we get to a calculator, it'll make a lot more sense. I hope this helps. Any questions, save them for Tuesday or Wednesday.